This is a PC. Yeehaw.
Okay. So we're going to talk about circuit components. We're going to do 8 more questions.
Go for it.
And
how often is the extra test given? In other words, you go through and you study all of this, which is a great refresher for a lot of us. And then all of a sudden we need maybe a month just to go through it intense on our own. So can you get the test taken on a frequent basis? Is it given on a frequent basis, or how does that works?
well, around here, there's every other month, there's an exam held at Suntree Public Library on Saturday mornings.
Mhm.
In the alternate months, there's one held down at the volunteer or the fire training station in Melbourne.
Mhm.
And every third Tuesday of the month, we have one out at Cars Park. And then there's an online done by the Marshall Amateur Radio Club, which is the third Thursday. There's one coming up this Thursday.
Mhm.
And sometimes they do it on Sunday. And they will do a special session if, you know.
ECAT.
Who?
ECAT.
And who's that?
That's Ricky DeLuca's group up in Mims.
Yeah, that's
Okay.
the first Sunday of odd number, or I'm sorry, first Sunday of even numbered months. So his next exam will be December 3rd. So plenty of opportunity.
Yeah, at
Yeah.
least once a month, there's an opportunity.
Yeah, because if you don't get it done by June 2024, then everything changes. A lot of things change, right? New questions, quite a bit of stuff changes.
Right. Well, I don't know how much, but yeah, they will change. I just went through updating the general because it changed last July. And it really was more rewording questions. The answers were the same. And they changed a lot of the wording of the wrong answers, but they didn't add that much new stuff.
Yeah,
So it's hard to say what they'll do on the extra.
Did you mention that the one at Cars Park, they don't charge a fee for testing?
No,
It's
well, they do for
Okay.
technician.
Okay, all right. Isn't it like Laurel?
Laurel is the only one that doesn't charge,
Right.
and that's the Suntree.
ARRS.
Right. But none of them charge for an upgrade.
Right,
Okay. Yet.
yeah.
And the online one with Marshall is now being done by a different VEC, the Central America VEC, and they're only charging $10. ARL is still $15. Morning.
Morning.
Morning, Jack.
Morning.
You didn't miss anything. We just got started.
Good. Yeehaw.
Huh?
Yeehaw.
Okay. And of course, no, it's not going to work today. Worked last week. All right. So, huh?
It's like a lot of things.
Yeah. First thing we'll talk about is reactance. Basically, with phase modulation and balance modulators, detectors, and mixture stages. So modulation is just the process of adding information to some kind of a carrier. It could be digital or analog. Most of the stuff we'll deal with is frequency modulation and phase modulation, which is related. I'm not sure you can do one without the other, actually. Amplitude modulation, single sideband being what we mostly use, which is a special case of amplitude modulation. So for FM or PM modulation, we need to have a modulator that can vary the phase or the frequency of the signal. And normally you do that with some sort of reactance device, either a variable voltage variable inductor or capacitor. Normally it's a voltage controlled capacitor called a varactor. Sometimes it can be done by using the capacitance of a p-n junction in the transistor as opposed to a separate device. And that will allow you to change the phase or the frequency. The formulas down there show what the actual difference is. It turns out that it's easier to do phase modulation than it is frequency modulation. There's another integral term in there, but I can't actually tell you what the physical difference is. I haven't gone down that rat hole long enough. What I did discover that maybe I knew once upon a time is that the integral of sine x was minus cosine x. Just for those people that care about math. This is an example of frequency modulation showing the amplitude of the baseband signal, changing the frequency of the carrier. And this is what the spectrum would look like. And you see those spectral bars out there. The bandwidth of that, I believe, maybe somebody remembers Carson's rule. I think it's twice the modulating frequency plus the deviation.
Doesn't sound like Kit Carson.
Something like that. It's on the extra exam. Don't worry. This is a typical varactor modulator where you can see it's kind of in parallel with the tuned circuit of the oscillator so it can change the frequency. And we do that by changing the, well, affecting the bias. It's biasing the diode in the negative direction. So the modulating signal varies the amount of bias, reverse bias on the diode, which changes the capacitance. So which of the following can be used to generate phone emissions? What's the function of a reactance modulator? Do you know what an electrically variable inductor is?
Yeah, that's a good question.
I mean, they say that in the text, but I have no idea what one would be.
Yeah, I'm not sure how you would do that. Was that millihenries?
I don't know. I mean, you could do it mechanically, but it wouldn't be very fast.
That should be on my thing, right?
Yeah, me too. All right, FM modulation. Normally, at least for broadcast, and I'm not sure on amateur FM, do our transmitters use preemphasis?
I don't believe so.
Yeah, I think it's basically FM broadcast.
Yeah.
But the preemphasis network is, from my understanding, like voice compression on AM or single sideband, where it shifts the frequency up. Yeah, so the higher frequencies are accentuated. And then on the other end, you need the de-emphasis, which does the opposite. And they also say they have to do it to maintain compatibility with transmitters using phase modulation. I trust them on what they say. I don't understand that. But it is a question. So what circuit is added to an FM transmitter to boost higher frequencies?
D.
Why is de-emphasis commonly used in FM communication receivers?
A.
I. You get an extra donut.
Amplitude modulation. So we produce AM and single sideband using mixer circuits. You take the carrier frequency and the baseband, input them in a mixer, and you get an amplitude modulated output. In this case, carrier is the frequency that's carrying information, and baseband is the frequency range of the modulating signal. So when you do the mixing with a normal mixer, you get four outputs. You get the carrier, you get the baseband, and you get the sum and difference of the two. Unless your modulation is too high, and then you get harmonics, which are they call spurious products. This just shows typical amplitude modulation, modulating the carrier at 100% modulation. And what the spectrum looks like, and you see the carrier, and you see the two sidebands, which are the basebands, sum and difference. And you don't see the fourth component, which is the baseband, because it's off the chart. It's way down, way over to the left.
It's not modulated.
No, it's the baseband signal at its frequency, just like the carrier's at its frequency, and then you get the sum and difference with the products. This one is showing what the actual math is for AM modulation and what the baseband signal looks like. And I don't know how they explain the negative, but there actually is an imaginary component to these frequencies. So the baseband is plus and minus frequency, and the carrier is the positive and the negative. Therefore, you get the products in both the positive and negative.
And that's going to be J.
I guess that's J, imaginary, or maybe it's phase. I'm not sure what that represents in the real world. So what's meant by the term baseband?
The range.
Yep. What are the principal frequencies that appear at the output of a, probably should say, mixer circuit? Not sure where to put these guys.
You could hit the minimize button up the top there, yep, and that'll hide it.
Okay.
Let's see.
Yep.
To the inputs and the sum and difference. So what happens if we apply an excessive amount of signal into the mixer?
A.
Spurious mixers. Single sideband, like I said, is a special case of AM. Use it for phone transmission on HF bands because of the narrower bandwidth. So it's better for weak signal. Also on VHF and UHF. In order to generate single sideband, you need a balanced modulator or balanced mixer or a double balanced mixer, which is normally a ring diode. In other words, 4 diodes connected in a ring between a couple transformers. And the difference between that and a regular modulator, it only produces the sum and difference. You don't see the carrier and you don't see the baseband signal. So you only have the upper and lower sidebands coming out of the balanced mixture.
Like on a sideband signal, it's about 3 kilohertz, right?
Depending on your baseband, yeah.
So what's an AM band? Is that going to be
Twice that.
It's gonna be just twice that, and the
Well,
carrier.
because you
would be
got both
right-
sidebands
The carrier would be right
in the middle.
between at the,
Right.
at the edge.
And you're gonna have, for AM, you're gonna have the carrier, and you're gonna have the base of the upper sideband and the lower sideband. So you're gonna see the double, plus and minus.
When you demodulate like a AM signal, what does it look for to get the information? The
It's
carrier
coming up.
or the.
The special mixer,
Yeah.
does it wear a padded helmet
Some,
and walk around with an adult?
some,
Okay. And we have to follow the balance mixer with a filter because we want to get rid of one of the sidebands. So what is one way a single sideband phone signal can be generated?
Ooh, alpha, balance modulator.
Alpha sounds good.
you said balance mixer, the same
Balance mixer.
or modulating?
Yeah, it's really a mixer. But the process of mixing modulates, so it's kind of. So to demodulate an AM signal, we use what we call an envelope detector, which is really just a rectifier, a diode and a filter. Because all we're doing is getting the low frequency component out. In other words, the envelope of the waveform. We're filtering out the carrier or the higher frequency part of it. This is a typical envelope detector. I actually did this one on my circuit lab simulator and it worked.
Does it tell the size of the envelope, like letter or?
Legal document.
Yeah.
Probably has to do with the gain of this transistor circuit following it here. But as you see, the detector is just this diode and the capacitor feeding this little amplifier. So how does a diode envelope detector function? Delta. Alpha. All it does is
D.
rectify the signal. And you get what you're getting is varying DC. For a single sideband, we can't do it that way. Because there's no carrier there. It's, in fact, I've yet to find an actual picture of the envelope waveform for single sideband. It's kind of weird because there's really no reference. So you have to use what they call a product detector, which is again a mixer. So you're going to mix the beat frequency oscillator with the IF frequency, and the product of that is going to be the audio output.
Development or someone has a cute kit. Instead of having a variable frequency oscillator for tuning, it uses a frequency oscillator.
And that's also why when you tune in single sideband signals, you get the rain barrel and the Donald Duck, because there's no reference carrier to know what the actual offset is. This is a typical product detector I found. Your IF is coming in over here, and this number 3 down there, I'm not sure what that represents, is where the beat frequency oscillator would come into the mixer. So you'll get the sum and difference and the BFO and the IF frequencies. What type of detector circuit is used for demodulating single sideband?
Charlie.
That's the basic difference. Product detector for single sideband, envelope detector for AM. For FM, we got to use a whole different process. We call it a discriminator or a ratio detector. And it is just a circuit that can convert the frequency changes into amplitude changes. So it's going to go from frequency to amplitude.
So it can be represented in audio.
Right. Because the modulation information is the frequency change.
Right.
And you need to get it back into amplitude. This is a typical discriminator or ratio detector. I'm not entirely sure how it works, but it appears that you have some sort of balanced signal between these two capacitors and the resistors in this rectified network, and some offsetting signal here that unbalances it, I'm guessing. You don't have to know how it works. And I don't understand how it works yet.
Could you explain IF again? What I saw the term IF, I've forgotten what that is. Intermediate, I think it stands for intermediate frequency, right? IF.
Right, intermediate frequency.
And that's
the-
before you, I guess if you receive, when you're receiving a signal, it's in the atmosphere and you got to do something to get it down to intermediate frequency, right? And
Right.
then, right.
Normally, you mix it with a different frequency to basically frequency shift it to normally a lower frequency. So you can, it's easier to filter it and amplify it.
Mhm.
In some cases, I don't know, they do it as much in the modern radios, but older radios, they may have two IF stages where they get it down into the megahertz range, and then they normally convert it down to like 455 kilohertz, and in some cases they even went lower than that. So what is a frequency discriminator stage in an FM receiver?
D.
Okay.
Fill in the blank.
The other than IFs, if you look at the handband, you got 40 meters, 15,